So let's now talk about finding volume of prisms and cylinders, and then again, we'll do volume of pyramids and cones. We did surface area already, which remember is akin to painting the outsides of your figure, whereas volume, if we'll read the formal definition, says the volume of a three-dimensional figure is the number of non-overlapping unit cubes of a given size that will exactly fill the interior. So we're filling it up, right? And so the volume is how much can you fill it up, basically. So if you look, we've got these two different formulas, which again, just like surface area, they're very similar, but they're more specific to prisms versus cylinders. So the volume of a prism with base area capital B and height h is V equals capital BH. So again, that capital B represents the area of the base. Area of the base. Okay, and remember that base is the bases are the congruent polygons. Okay, these two other formulas that they have, these are the exact same formula, but they're just more specific to rectangular prisms. Okay, so if you know the general formula, which is area of the base times the height, you don't need this specific formula, because it's going to apply the same way. That one is just specific to rectangular prisms. Now, the cool thing is, before, when we were doing surface area, our formulas only applied to right prisms and right cylinders, whereas these are true for right and oblique figures. Okay, which is really cool. Right, and oblique. And remember, oblique are ones that look like this. They're at an angle. Now, the formula for a cylinder, again, it's the same formula, except now we're specific for a cylinder. So the volume of a cylinder with base area B and radius R and height h is V equals area of the base times the height, or because we know that the base is always a circle, we can replace that capital B with a pi r squared. And again, it also works for right and oblique. Okay? And you're going to see that volume is actually a lot more straightforward than surface area was, because we don't have to go and figure out, okay, which figures, which ones are the bases, which ones are not, which can I include, what can I not include. Volume is going to be pretty straightforward every single time. So we're just going to do 3 examples. 2 of them are, one's a prism, one's a cylinder, and then the last one is a composite figure. So it says, find the volume of the prism round to the nearest thousandth. Okay, so our answer is not going to be exact. So it's asking me to find the volume. So the general formula is V equals capital BH, which again, remember capital B represents the area of the base. So if I look at my base, it's the congruent polygons, not the parallelograms. So the parallelograms that go around, that's not what I want. I want that top and that bottom. Will it always be the top and the bottom? No, it could be the left and the right. It could be the front and the back, but it's the 2 congruent polygons. So when I look, first of all, I have to figure out what shape is that. It's very clear to me. It's not a rectangle. It's not a triangle. It's not one of our few basic shapes that we deal with all the time. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have an 8-sided figure, so I have an octagon. Since this is an octagon, I'm going to have to put in a little bit more effort to find the area of the base. The first thing I'm going to do is I'm going to draw that little bottom section like I always do anytime I have a regular polygon or anything that's not just your basic rectangle, square, triangle, etc. Okay, now, do I know that those angles are perfect? No, but that doesn't matter, because the formula for the area of the base, or for any regular polygon, is A equals 1/2 lowercase a p. But I'm going to erase that A and I'm going to change it to a B, okay, because it's the area of the base. So I know that this segment here is 10 millimeters, which means the perimeter is going to be 10 times 8, which is 80. How do I know that? Well, because it's a regular polygon, right? So each side is 10, and there's 8 sides, so it's going to be 80 millimeters. That's great. Now I got to go find that lowercase a, which is the apothem. Remember, the apothem comes straight down from the center. It bisects this side right over here. And our job is to find that A. And I'm going to do that, if you guys recall, by creating a right triangle right over here, and then using that right triangle to find the length of that leg. But the question is, do we know if it's a special right triangle? Is it a 30, 60, 90, or a 45, 45, 90? I don't know that until I go check my angles. So remember, I'm going to extend this side out, and I'm going to find that angle. Well, that angle can be represented by 360 because all of the exterior angles in any polygon add up to be 360, or any convex polygon add up to be 360 degrees. And there's 8 sides, which means 360 divided by 8, and that's 45 degrees. Now remember, the radius is going to bisect these two angles here. Okay, so what I'm going to do is I'm going to do 180 minus 45, which is 135 degrees. And I'm going to bisect it. So I'm going to go divide that by 2, which makes each of those angles 67.5 degrees. Okay, 67.5 degrees. Since that angle is 67.5 degrees, there is no way that I'm going to be able to use a special right triangle. I'm going to have to use sine, cosine, or tangent, depending on what I'm missing and what I have. Well, remember how we said that this gets bisected right over here? Well, that means this is 5 and this is 5. So right now we have this triangle. Okay? Where this is 67.5 degrees. This is A, and this is 5. So when I'm talking about that angle in relation to my sides, this one right here is opposite, and this one right here is adjacent. Well, when I'm talking SOHCAHTOA, the only one that uses an opposite and an adjacent leg is tangent. So I know that tangent of 67.5 is equal to opposite over adjacent. My opposite is A, my adjacent is 5. So to solve for A, I'm going to multiply both sides by 5. So I have 5 tangent 67.5 is equal to A. So right here, I'm going to say 1/2 5 tangent 67.5 times my perimeter, which we figured out was 80. Okay, and you can go simplify that further before you substitute it back into your formula, or you can leave it the way that it is. But currently you do have an expression that represents the area of the base. I'm going to go simplify it just a little bit more. So I'm going to say this is half of 80 is 40, and then 40 times 5 is going to be 200. Let me leave it in pink. So right here, I have 200 tangent 67.5. That represents the area of the base. And the height represents the height of my prism, okay? The height of my prism is this segment right over here. All right? So that's going to be 15. And so then I just type that into my calculator and I simplify. But remember, these are angle measures that are in degrees. So before you do anything, you need to make sure that your calculator is in degree mode, and then just type that directly into your calculator. And if you do it correctly, you're going to get approximately 7,242 it says round to the nearest thousandth, So I'm going to say 641 millimeters. And since this is volume, and remember in the definition it talked about units, cube units, so it's going to be millimeters cubed. So our volume is approximately 7,242.641 millimeters cubed. All right. That's kind of as hard as they get for you to have to go and break it down into that regular polygon. If it's just your basic rectangular prism or triangular prism, it's going to be a lot more straightforward, but I wanted to do one with you that's a little bit more complicated as a reminder. The next one just says find the volume of the cylinder. I know it looks like there's more written behind where my video is at, but there's just a period. So the formula for volume of a cylinder is V equals capital BH, just like before, but remember we can specify, and since the area of the base is a circle, it's going to be pi r squared h. And how nice for us, they gave us the r, this right here, that's our radius, and they gave us the h, this right here, that's our height. So all I have to do is substitute. Notice this one does not tell us to round, so our final answer is going to be in terms of pi. So I have pi times my radius, which is 24, squared, times my height, which is 33. And then all I have to do now is type this part into my calculator, this part right over here into my calculator, and that leaves me with 19,008. Okay, pi inches cubed. So our volume is 19,008 pi inches cubed, and that is it. Let's go do a composite figure. All right, let's take a look at this composite figure. It just says find the volume of the composite figure, round to the nearest tenth. Now, the really cool thing about volume that's not true about surface area is we don't have to say, oh, okay, this base is showing, this base is not showing, this gets covered, this doesn't get covered. For volume, volume is volume is volume. All you have to do is see, am I adding two volumes together or am I taking volume away? If you're adding volumes together, then you're going to add. And if you're taking away, then you're going to subtract. That is really the only thing that you kind of have to watch out for. So again, I know that this is a composite figure. All I have to do is figure out, okay, what are the figures that are being composed together? So I can see that this one down here, that's a rectangular prism. Up here, that's a triangular prism. So to find the total volume, I just have to add those two together. So V equals volume of the rectangular prism, RECPR for rectangular prism, plus volume of the triangular prism, so TRIPR. All right, so the formulas are the same. Area of the base times the height plus area of the base times the height. The difference is that the base over here is going to be for my rectangular prism, and the height is going to be for my rectangular prism. Here, the base is going to be of my triangular prism, and the height's going to be of my triangular prism. So let's do the volume of the rectangular prism first. So again, it's area of the base. So base of the rectangle is going to be length times width, which is 8 times 4. Let me use a different color. Eight times 4, which is 32, which makes the height 5. So 32 times 5. And now I want to add on the area of the base of the triangular prism. Now be very, very, very careful here. This is called a triangular prism for a reason. And that reason is that the base is the triangle. So don't think, oh, this right here, don't think this right here, that's the base of the triangular prism. It is not. It's this triangle right here that's the base of the triangular prism, right? This is the shape that I have going on. my base is this triangle that's kind of highlighted in yellow, okay? This right here is one of my lateral faces. So this, when you're finding capital B, you're not looking for this one, you're looking for this one, okay? So I want to do the area of the base of my triangle. So base of the triangle. Well, I know that that formula is 1/2 base times height, but notice we are not given the height. Okay, we're not given this height right over here. So let me go ahead and draw that down. That's the H, okay? So I have this triangular shape. I need to find this height right over here. And I know that this side is 8. These two are bisected, so that's 4 and that's 4. Since it is an equilateral triangle, because that's what we know, right? It's going to be equilateral triangle because it's going to be a regular polygon. That's 60, which makes this a 30, 60, 90. So 1 radical 3, 2. The 4 is the short leg. I'm looking for the long leg. So I have 1 times height, which is height, 4 radical 3. Now, eventually you are going to round to the nearest tenth, but not yet. You want to leave it the way that it is now. So I have 1/2 times 8 times 4 radical 3, because that's what I just found. So I can simplify this further and say that this is 1/2 of 8, which is 4 times 4 radical 3, which of course is 16 radical 3. All right, so right here I have 16 radical 3 times the height of my triangle, which, sorry, is the height of my prism. So again, this height right here, I'm trying to make sure that y'all can see it. This height right here is the height of the triangle. But when I look at this prism, I want the height of the prism. This is not the height of the prism. This is the height of the triangle. So if I turn this, it might be a little bit clearer, okay? This is the base. This is the height of my prism, okay? And so the height of my prism is actually this right here. And that's going to be 4. Oh, I already used green. I got to use a different color. Okay, that's this one right over here. That's 4. And then I can type all of that directly into my calculator because, again, it says round to the nearest tenth. So V is approximately 270.9 centimeters cubed. And that's all there is to it.